I am back. Look at this. So I'm doing the part two of the project for hypothesis testing. So hopefully this is clear for everybody. Just let me know if you have questions about it. I'm going to share my screen and let's get into part two of the final project. So if you go into your modules, you will see that I am up to, we're up to additional topics on inferential statistics, which is basically the end, right? We've got a quiz that I'll go over. We've got a chapter 9 review assignment, a chapter 9 review. We've got a NOVA to do. And yeah, so I'm going to start with this project part two hypothesis testing. So using the data chosen in part one, you can modify it based on what we're doing for this section three, which is hypothesis testing. So do hypothesis test the following answer and also do a 95% confidence interval. If you forget how to do them, I've got videos how to do other parts. So we have to state the hypothesis, the critical values, summarize the results. So these are the 5 steps of the hypothesis testing. Your modified project part one, part two with 2 hypotheses included. You must include all 5 steps in a Word document, blah, blah, blah. If this is not an A or B paper, I will return it to be corrected. I don't know if I'm gonna be that, but we'll see. So here we go. So I'm gonna copy that. I'm gonna open Word. And I will make a hypothesis for the I think I was doing vision. Yeah, I was doing vision for this. So here we go. So I'm gonna first go to StatCrunch and pull up the data. Um, and I think, oh, this is perfect. I want to show you how to do a t-test by hand. I knew I was gonna get a chance to do this, so I'm gonna do a t-test by hand for you guys. Do you have to do a t-test? No, use whatever you'd like, but I'm gonna do a t-test of means that aren't the same. And yeah, that's what I'm gonna do. Hopefully that's exciting. So if that's boring for you, that's fine. But I knew I would get a chance to actually show you one of the most common things done in stats. We're gonna do, I think we'll do a mean score for the left eye and the right eye. So each person gets a full vision score. Um, and then we're gonna see if those are equal for men and women. That's the plan. I'm gonna do it by hand. Um, and then I'm also gonna use the stats. I hope you're excited. So here we go. We could do it on Excel and StatCrunch. I'll show you all through these. So this one will probably be a long one. If that's boring for you, I'm sorry, but at least I get to teach you. I feel like this video I get to teach you a lot. So, all right, so here we go. The first thing I need to do is get the data. All right, so let's get this data. I think I'm also gonna just make an extra part of this. And perfect. I'll leave it right here. I'm gonna call this final project t-test with unequal means example. So I have a place to do all the math. All right. So uh, I want to go to where the data set is, but I think that's in just regular StatCrunch. Just go to my data. Maybe it's there. That's yes. Okay, so we got to find the vision one. I think this was it. Yes, cool. I like it. I like it a lot. So, where did it all go? Did I just mess something up? Just gonna click it again and see what happens. It looked like there was more. Yeah, age. All right, well, we could do something and see if age messes with vision, we could do that. We could say the older you are, the worse your vision is. We could do an ANOVA with age and gender, and we could look at both. But just so it's not too crazy, right? Just so it's not too crazy, I'm going to do a average score for each person. So first thing I'm going to do, I'm going to actually highlight everything. I'm just going to put it into Excel just because I'm like better with Excel. I've never used StatCrunch before, like a week ago, 2 weeks ago. So, yeah. So I just find it easier for me to work with Excel. So here we go. The first thing I'm going to do is I'm going to separate these by gender. We're not going to let age mess with us just yet. So the first thing I'm going to do is I'm going to go to home and I'm going to sort this. And I have to expand it because these all match. The age matches. This is a single person. So we've sorted. So you could just do a basic correlation for age and eyesight, but that's fine. So right away, gender, I think female was 0 and male was 1. Now I'm going to give you that every person a score. How am I going to give every person a score? I'm just going to put eyesight score. Obviously, the lower is the better. So I'm basically just going to do the average of these two. So I'm going to do equals this plus this. I need parentheses around it. I'm going to divide it by 2. So this is going to be a score for every single person. So right away, I have an eyesight score for everybody. The lower it is, the better it is. That's everybody's eyesight score. Looks beautiful. I like it. We have more than 30 people. Since we're working with means, guess what? Central mean theorem. Doesn't matter if I'm normally distributed, which is really nice. All right, so I have an eyesight score. I've got my girls. How many girls do I have? Sorry, my bad. I have, looks like I have 154 girls. We have 300, so 146 boys. Or you could do ready equals 300 minus 146 boys. Okay, so the first thing I want to do, you see they're different, right? We have a t-test, they're going to be different sizes, right? So because they're different sizes, you'll see the formula is going to be a little bit different, but that's okay. All this is going to be okay. So our mean, right? So the first thing we need is a null hypothesis. Our H0 or null hypothesis is that oh wait, I have this so I can draw. So the null hypothesis is that we don't have all the girls, but we could just say that the mean of our sample of girls is equal to the mean of our sample of boys. Now we could claim they're better, one's better than the other. We could say we want to prove that the girls have better eyesight than the boys. Now, for all of this, the best way to think about t-tests with unequal groups is the first thing we do is we just look at the formula. So I'm in setology. So obviously it says we can do it. The real issue is whether two samples do not have equal variances. All right, so the first thing we have to do is check the variances. So we have to check the variances of the girls and the variances of the boys. So right away, in order to run this thing, we have to see if they have equal variances in order to do this. So we know that this is our identifier, or you can call it a label if you want. This is our n. We could do the mean of each eyesight value, but we basically just want we need the variance, so we could do the standard deviation. Well, let's just get the mean first of both. Then we're gonna do the standard deviation, then we'll do the variance. So first way to get the mean is let's highlight all the girls. We don't go down to 150. Oh, I was fast. 154. 155, sorry. So that's their mean score. Now the mean for the boys equals average. We know it's going to be E 156 to E 301. You could check to make sure it's where you want it. Ta-da. Ta-da. All right, that's the mean. Now we do the standard deviation equals STDEV dot S E1, sorry, E2 to E55. And then we can literally just copy this. Then I could do, ready? E156 to 301. All right, and now to get the variance, we just have to square them. So we might not even be able to run this test because those variances look pretty different. 580, 2085. So following code shows how to create a box plot in R to visualize the distribution of each program. Okay. The mean of exam 2 appears to be higher uh, than the various exam scores between the two programs. It's roughly equal. Okay, so they're saying the spread looks pretty similar. So we could make some box plots. Sure. Make a box plot. Now we need to get these values starting at 155. I don't know what just happened there. So if something weird happens, you could always just undo. You should be good to go. So in order to make the box plot, I'm just going to highlight this. Considering I'm already working with the data, copy this, open a new sheet, drop it on. Oh, it's because I lost the reference. All right, so I'm gonna take half of this. 156. Okay, so they're not letting me grab them all. I see. I see. So how can I do this twice? So I could take this from 155, 156, sorry. I could delete all these, copy it. Boom. All right. 154. So I start at one. It's 154 and I'm here. That means it's all the way up to 155, which means I start at 156. Cool. This needs a 20. Okay. Now here, gotta be kidding. I won't let me copy and paste it. And all I want to do is make a two simple box plots. So I'm gonna just get rid of this sheet completely. The sheet itself. Yes. All right. So this is how I'm gonna do it. All right. So here we go. That's the first one. Here we go. Here's the second one. I don't know why that was so hard for me to do, but then again, it's all in the struggle. All right. So all I need is C, insert box plot, and that looks strange. All right. Now let's put the other one next to it. I wanted them to be on the same piece, but it just doesn't want to be my friend. Let's look at the spreads. Mhm. All right. They look pretty similar. We have them right next to each other. They look pretty similar. Why is this one only at 40? But those those ranges look pretty close. So our test of variance is assured. We're pretty good. We've tested for that piece of variance, so they look pretty much varied. I like it. The independent samples t-test. So example two. This one doesn't have it by hand. I was just gonna put the one. Uh, independent samples t-test. Here we go. Let's make the formula happen. Cool. Here we go. Here's the t-test formula for independent samples t-test. Mean one minus mean two, pooled variance, and there's where the pooled variance comes from, sum of squares, degrees of freedom. Cool. So this is how we're gonna get the test statistic for this. Mean one minus mean two. And all we have to do is, if you don't know how to get the pooled variance, we get the sum of squared. So this is the first formula we have. And this is a way, because right now, right? Like if we look at our Excel, right? The means, like we want to say that girls have better eyesight than boys, right? Right now, they're like 3 points higher. I mean, oh, the guys are 3 points better because you're on lower, right? But is that true, right? Is that true? You know, we don't really know yet, right? We're not really sure unless like nobody's gonna really take our word if we're just like, well, the means are different. There's other factors at play. You know, the variance is different, even though it's not that much. We looked at the box plot. These are different. So you can see that this would be girls have worse eyesight than boys. I want it the other way. I want it to be, I was hoping they'd have better eyesight, but I guess we could just say boys have better eyesight than girls, and then we'll see what happens. So here's the formula. Mean one minus mean two. So X bar of boys, sorry, it's girls first. X bar of girls minus X bar of boys over. And our T statistic is pooled variance over N1, pooled variance of N2. Pooled variance of N of girls. Oh, sorry, it's over N of girls. So pooled variance girls over the N of girls is a minus or plus, plus the pooled variance. Oh, the pooled variance is the same. Pooled variance is the same. So SP over the N of girls plus the SP over the N of boys. That a big G. And then how do we get that pool variance? I wish that there was a better. Pool variance is N1 minus 1. And I believe that is the variance plus N2 minus 1 over the variance. Yeah, there we go. Is that what they had before? Oh, it says sum squared plus 1 over degrees of freedom. I just like the way that picture looks. There's so many different ways they show it. Pooled variance provides an unbiased thing. Okay. Well, degrees of freedom 1 plus degrees of freedom 2. But they're not showing you how to get the sum of squares. That's the standard error of it. Here we go. Degrees of freedom, variance of 1 plus degrees of freedom 2. Yeah, there we go. I like it. I knew I'd find a good picture. So here we go. And we're going to use the computer at the end just to show that it's exactly the same. So don't worry. It's too scary for you. We're just trying to figure out the pooled variance, which we know is df of 1 df of 1 times the variance of 1 plus degrees of freedom of 2, variance of 2. And then it is degrees of freedom of 1 plus degrees of freedom of 2. So we already have all of these values. We already have all the values for this pooled variance. So we should be good to go, as long as we have the values, we should be fine. This is mean of standard error. I'm just seeing what they have. Okay, so yeah, that's what it is. Cool. Degrees of freedom 1, variance, degrees of freedom 2, and then that's -2. Yeah, so it's the same thing. It just depends how they write it. And then if we multiply that, we get this over the standard error, which is this business. Well, the final formula to compare two independent means with a t-test. All right, well, we can use any one of these. There's so many, right? We could use this where this gets dropped in. We can use this one that has all the pieces spread out. It's whatever really makes sense to you, right? Whatever is really going to make the most sense to you. I think I'm just going to use the whole thing. But to get our t statistic, it's going to be our first mean of girls minus the mean of boys. I'm going to do these things one at a time. So girls minus the boys, that's the top. And this is to get our t value. So the numerator is going to be equal to the first mean minus the second mean. So 3.136008. All right, now the next part is the bottom, the first part of the bottom. Which is degrees of freedom of 1 Okay, so that mess, degrees of freedom of 1 times the variance plus degrees of freedom of 2 minus 1 times the variance. Okay, so our degrees of freedom for the girls, right, is 153, and the boys is going to be 145. So basically, all I have to do is times that by the variance of each of them. So here's the first part. So we have degrees of freedom of boys, right? And to get it, it's squared. That's why it has a square root on it. But basically, it's just going to be the girls is first. So 153 times the variance, which is 801.8324 plus 145 times 336.162. This is going to be divided by the 2 degrees of freedoms put together. So get the total. We're just going to equal. And it should just be 2 less than the 300, which is exactly right, which is 298. So that's the first part, right? And then we take the square root of this thing. So that's obviously the first part of this for the SP. So the first part of this is, that's our numerator. And this is our pooled variance. That's what this stands for. The SP stands for pooled variance. We just have to take the square root when we're done to standardize it, So basically it's 1. So it's going to be equal to this value times this value. Cool. Plus this value times this value. You can put parentheses if you want, but the computer is going to obviously multiply before it adds. If you want to do that, you can. It's up to you. All right, that's the top. And then we have to take this value and divide it by 298. All right, so there's our pooled variance. And then we have to take the square root of that. So all we have to do for this SP is we do equal square root of the one above. So 23.982. So I'll bold this one. That's the whole, said I will bold this one. I'll bold that one. So that's the top, that's the bottom, but there's the other half of it too. So we have to account for this piece, which isn't that big a deal. And you could obviously see why we let computers do all of this for us. So we have to multiply this denominator 1 over n of 1 plus 1 over n of 2, which isn't a big deal. N of girls plus 1 over n of boys. Just going to double check and make sure that's the formula. All of that is in the denominator. I don't believe that is square rooted as well. It is square rooted, so I have to wait on the square root. So all I have to do is, we could do parentheses 1 divided by the first n plus parentheses 1 divided by the second n. So that's the other value, and I believe that's what we have to add it to. Oh, we multiply it. So basically, our last step is we have to square root, which is just going to be this value times this value. So that's the denominator. Well, we did have our pooled variance, but we needed the denominator. So basically, this is just our numerator. That's our denominator. So to get the t-statistic, all I have to do is equal this one divided by this one. So here's our t-stat, 1.139. So we got it. Then you look at a critical value based on we could use a 0.05 level for this. We'll make our alpha 0.05. But let's just make sure we got the t-statistic correct. So you could use StatCrunch too, but basically you just want to know if these are actually different, right? Let's see if these are actually different. So if I go to data, I go to data analysis, they should have a independent samples t-test. T-test, two sample equal variances. We could do two sample unequal variances because the variances don't look that equal, but we're going to assume that they're equal because we looked at the box plot. Variable one range is from here all the way down. Oh God, I went way too far. 155. Excuse me. So here it is. Our variable two range is basically going to be the same thing. Now we're starting at 156. Boom. Do we have labels? No, no labels. Our hypothesized mean difference, we don't really have one. But basically all I just have to do is, yeah, we'll just put it on a new page. Boom. Here's our t-stat. We did it right. Ta-da, 1.13. Now, if we were doing two-tailed, which is what we have, right? It is harder to get two-tailed because we didn't know that there was a difference. Oh, no, we said that the girls would be better. So if we had a one-tail, it's not less than 0.05. And the two-tail, definitely not. See how it's easier to get the one-tail? But either way, we're off. Our t-stat is below both these two critical values. So it's not significant. Girls do not have worse vision than boys, even though it's said that way. So that was how to do a t-test by hand. And then we could also do it with StatCrunch if we wanted. But that's how we can prove. So we have to reject the null hypothesis that 95% aren't done. I mean, we have to reject the notion that we are 95% confident that girls have better eyesight than boys, which is what we were like. Yeah. So we just did the entire thing with a t-test. I bet I could do this with StatCrunch. Let me just move my floating head. A t-statistic, two sample. We have the summary. Perfect. So here we go. So our sample mean for the girls was 32.14286. Our sample standard deviation. Well, I can just take the square root of that. So is 28.1.31665. Our sample size for the girls was 154. Now the sample mean for the boys was 29.00685. And like notice that like here you're like, oh man, if I only said it was like one-tailed, I'd have a better shot. Like that's why we always have to decide before we run the test. Like we have a reason that it's different, girls and boys, then we know. It should have been a two-tailed anyway, so we'll make it two-tailed here. All right, so the sample standard deviation for this one is going to be equal to square root of this one. So that's this one. So it's 18.33472. Our sample size here is 146. That's fine. We could pool the variances. That's fine. That they're equal, that they're not equal. Let's show the critical value. And let's not pool the variances. And then we can try it again. So let's hit compute. So the p-value is 0.2535. Here it is, 0.258. Okay, it's a little bit different. Our t-stat is here says it's 1.144, 1.131. So everything's just like a little bit off, right? Everything's like a little bit off, 1.14, 1.13 degrees of freedom, 263.8, but we know it's 298. 0.2535, 0.258. Everything is like pretty close. Let's edit this. Let's see what happens when I pull the variances. It's so weird when I use the exact value that it still didn't do it. Oh, sweet. When I pull the variances, it's the same. So we had to pull the variances, which is fine. 2.58, 2.58, 1.13, 1.13, 298. Yeah, now that everything matches. So this is how you could do it on Excel. This is how you do it on StatCrunch. And how do you do it by hand? Oh, it was that big mess that I did on this other sheet. Uh, where I was like actually working them all out. So how do you do it by hand is with the formula. But either way, we could say that there's no real difference between boys and girls for eyesight. So this is a really good way. Like this is like probably one of the most common things. T-tests with different sizes. This is like probably the most common stat test. I'm glad I got a chance to show it to you. So now I get to go through the questions. Obviously, you can use the what we did before and all that stuff, but here we go. Oh, I guess it was in Microsoft Word where I had the parts. All right, so we state H0, H1, and identify the claim. All right, so let's actually do this exactly right. So here's number one. Null hypothesis, so H0, females and males will not significantly differ on mean eyesight scores. Ta-da! That is our null hypothesis. So our HO is basically this first sample for females is equal to the sample for males. Now our H1 is females will significantly differ on mean eyesight scores than males. Alpha 0.05. So we want to do a 95%. So this is our two-tailed test. So our H1 or HA is a two-tailed test. Ta-da. All right, find the critical values. So our critical value for this was our t-score is equal to 1.13. If I can find it. 1.13, 1.13 or 1.132. Okay. Oh, sorry, that was our test value. So our critical value. Now remember that for the t-test it moves, right? So we could see that our critical t is 1.96, right? So critical value is 1.96 or 1.97. Now, how can we get that? Well, we can go to this, right? We can go to the stats. We could go to normal, or we could go to T. Here's our T-stat calculator. Our degrees of freedom is 298 because we have what? We have two groups. So usually it's just -1, right? Be 299, but because we have two groups, our degrees of freedom is 299. And now all we have to do is put 1 point, we want our this to be 0.95. Now, because we have to do both sides, right? We have to do both sides. It's like we're at it's like we're between. So if I make this 0.95 here, you can see, look, it's going to be significant on one side if females have better, worse eyesight or better, and then on the other side. Because it's two-tailed, it got bigger. So that's why it's 1.96. That's where you get that from. So what I do, I would copy this and I'd paste that in. Oh, maybe they don't let me paste it. Yeah, they don't let you paste it. That's kind of annoying, but what can you do? I would screenshot this. I'd screenshot the calculator where I got the 1.96 from. All right, number three, the test value. What did we get? 1.13. Make a decision on whether to reject or fail to reject. So 4, we do what? Fail to reject the null. Summarize the results. So we can say, guess what? We're allowed to say right now, we are, you could say that, this is how I would write it. Let's write it the exact right way. So I usually use Statology to help me, but it starts with an independent samples t-test was run to determine if there was a significant difference in mean eye sight scores for females and males at the and you could put parentheses here, like you could put alpha is equal to 0.05, just to let people know. Now this test statistic, the statement here, they have it here, the statement. Oh, maybe not. All right. I'm just glad I did the formula all right. I didn't make any mistakes, which is always nice for me. So I'm gonna just go to reading research articles, the thing that I made, and we're gonna go to independent sample t-test. And then we're just going to go to the results estimate. We can check it with a calculator right here. Let's look at the results statement. Here's our independent samples t-test. It means we have two separate groups, and I'll write it exactly how it says. So usually I write a sentence first in my results section, basing on what would happen. Then here we go. So I'll actually just write it in. Why it's so small. The um the was it 155? Was it 155? I can't even remember. $300. Be 154. $154 female participants. And then I need the mean. Notice the mean is italicized. And then we also need their standard deviation. Mean is 32.14. Then you do comma, control I, SD, control I, space equals, I forgot a space here. And then I have 28.32. Compared to the 146 male participants. And I always just copy and paste this so I don't have to like keep messing with the italicized key. So once I do it once, I just copy and paste it. So there's 29.01. Standard deviation is 18.33. Oh, sorry. So we just have to write this way. There was no significant effect for sex. Then we have to start with the t value, control I for sex, control IT. And then it's going to be the degrees of freedom, which we know is 298. Sorry, control I, 298. Now we know we basically put in equals to that t statistic that we got, 1.1. Where are you? 1.13. 0.13. All right, and then I put comma, and they want the p-value. So we'll do p is equal to whatever the p-value was that we got. Our p-value for the two tests, the two tail, was 0.259. Comma, despite despite women or despite female participants. There was no I guess we don't need the ends here because it wasn't significant. So there was no significant effect for sex. Let me just say it this way. There was no significant effect for sex despite female participants scoring worse than male participants on the eye exam. All right, cool. So there's the first sentence. The first sentence, an independent samples t-test was run to determine if there was a significant difference in mean eyesight scores for females and males. There was no significant effect for sex, despite female participants scoring worse than male participants on the exam. So that is a full t-test example. If you're going to use StatCrunch, screenshot it. If you're going to use Excel, screenshot it. I want it, or if you're going to do it by hand, show me your steps. I want to know how you got your critical value. I want to know how you got your T statistic, whatever statistic you wanted. And then you got to tell me if you're going to reject the null or fail to reject the null hypothesis. And I want a sentence. Okay. And I really want a good sentence. So that is this video on the second part of the project. I hope this was useful. Feel free to reach out if you have more questions. I'm glad I could show you a t-test. I feel like t-tests are the most commonly used one. So I'm glad I was able to show you an example, not from the book, not from the test, of like the more common stats that I see all the time in research.